Hello students, today I will discuss one more question from GCSE Chemistry Foundation Tier Paper 1, Paper Code F, Thursday, 14 May 2020 morning paper. The question is about silver iodide. So silver iodide is produced in the reaction between silver nitrate and sodium iodide solution. The equation for the reaction is silver nitrate in aqueous form reacting with sodium iodide, giving silver iodide and sodium nitrate. Okay, so over here the question is a student try to investigate the law of conservation of mass. So what he used as a method is he first poured silver nitrate solution in a beaker A, then he poured sodium iodide in a beaker B, then he measured both the masses and their contents. Then he poured the solution from beaker B into beaker A, and then measure both the beakers and their contents again. Okay. Then from table 7 we can see in beaker A, mass before mixing is 78.26, mass after mixing is 108.26. In beaker B, mass before mixing is 17.5, mass after mixing is 48.5. So students, if we try to find out the total mass before, we need to add these two. And if we add, we get the value as 156.76 grams. And the mass after mixing in grams in both the beakers, we also get over here 156.76. Over here, thus we can see that the mass of the product equals the mass of reactants. Thus, we can say that the law of conservation of mass has been proved here. This is question 10, and the question 10 tells us about a chemical reaction taking place between silver nitrate, sodium iodide, which gives us silver iodide in solid form, and my sodium nitrate, which is also in aqueous solution. Okay, so over here, suggest how the student could separate the insoluble silver iodide from the mixture at the end of the reaction. Okay, since it is given that my silver iodide is insoluble in nature, so the method that we can use is filtration. So in filtration, we can use a filter paper where the insoluble silver iodide can be separated using the filter paper. So according to me, the method the student should use for the separation is filtration. Okay, students, so this question is from the continuation of question number 10. The question is suggest one impurity that was removed by rinsing with water. So the one impurity that I can suggest is my sodium nitrate. Okay, it's my sodium nitrate solution which can be treated as an impurity. So sodium nitrate is treated as an impurity that can be removed by rinsing with water. Okay, students, so this question is based on my question number 10, where we are discussing about a chemical reaction taking place between silver nitrate, aqueous solution, and sodium iodide, which is also in aqueous solution, and giving us silver iodide in solid form and sodium nitrate in aqueous solution. So based on this chemical equation, we are asked the question, suggest why the student warmed the silver iodide. The reason being the product is in aqueous solution. So if we want to remove it, okay, so we can warm it, or we can rather warming, we can evaporate the water. Okay, if we evaporate the solution part of the product, then we can get the solid silver iodide. So we need to evaporate the water. The water content of the product. To get solid, dry silver iodide, we need to evaporate the water content of the product. Okay. Then this question is also a part of question number 10, which tells us about a chemical reaction taking place between silver nitrate aqueous solution and sodium iodide in aqueous solution, which is giving my silver iodide in solid form and my sodium nitrate in aqueous solution. This question is based on this chemical reaction. Question is asking, give one reason why reactions with a high atomic economy are used in industry. Okay, so the answer to this question is in industry, they can produce higher percentage of useful products. And so that there can be also less of wastage and all. So more useful products will be produced, more the industry will be successful. So high atom economy is used in the industry.